are some symbols that you'll commonly see when looking at a balanced chemical equation. They're just symbols that are descriptive. They tell us what things should look like if we really ran this reaction. The S, solid, is super easy. Most people would have guessed that. Solid. Which probably means that the L stands for liquid and the G stands for gas. So again, just little symbols that we use to be more descriptive. If I were going to run this reaction, what should I expect to observe? Am I going to form a solid, a liquid, a gas? The AQ stands for aqueous. Aqueous. Or in other words, something that has been dissolved in water. So the trick is, it might look like it's a liquid, but it doesn't naturally occur as a liquid. For example, you could have sodium chloride, solid, or you could have sodium chloride, aqueous. Sodium chloride naturally occurs as a solid, but you could dissolve it in water, and you could use it as a solution of sodium chloride. Often you'll see that word with these. They'll say solution. Like if we're working in the lab and it says, add 100 milliliters of a sodium chloride solution, that means that it's aqueous. It's been dissolved in water. Now you could also use solid sodium chloride. So again, these symbols might kind of tell me either what type of reactant I'm using or maybe what kind of product I'm expecting to form. The aqueous is a little bit different than the L, liquid. You would never do sodium chloride liquid. No. That L, liquid, is probably the least used of all the symbols. It's only for something that naturally occurs in the liquid phase. So the most common thing we'll probably use it for? Water. Water naturally occurs in the liquid phase. Or maybe like an alcohol that naturally occurs as a liquid. Or hydrogen peroxide. But not sodium chloride. It would never naturally occur as a liquid. We would either use it as a solid, or we would use it aqueous, dissolved in water. I kind of mentioned energy, that you could have energy as either a reactant or a product. If energy is a reactant, the reaction is endothermic. If it's a product, the reaction is exothermic. In the lab, if I know a reaction is supposed to be exothermic, and I touch the outside of my beaker or test tube, it should feel warm to the touch. I should feel that energy being released. If I expect a reaction to be endothermic, it absorbs energy. It absorbs energy from the surroundings, so the surrounding air, the surrounding glass, beaker, whatever it might be. It often feels cool to the touch. Or another way of picking out an endothermic, you have to add energy to do the reaction. So if I'm in the lab and I read the directions and it says that I need to use the Bunsen burner to heat my reactant, that's probably an endothermic reaction. I need to add heat. The last two symbols, I don't know, I mean, they're cool. I don't use them as often. The upward arrow means a gas is produced. The downward arrow means a solid precipitate is produced. Is produced. Okay, so here's the deal. If you produce a gas, it will rise out of your reaction vessel. So that's why we have this upward arrow for the gas produced. If you form a solid precipitate, over time it will sink to the bottom of your beaker. hence the downward arrow. Notice too that these are only used on the product side. Only on the product side. And I mean, in reality, I usually just use gas. I just use the G for gas, and I usually just use the S for solid. But if you were doing these in a lab or you were reading in the textbook, you might see this upward or downward arrow, and it's really just helping you decipher the phase. A gas would be released, or a precipitate would sink to the bottom of your beaker. Again, you could still use gas or solid. So these symbols are really easy, but they'll help us give a little more detail to our balanced chemical equation.